Good evening, everyone. Well, at least good evening, good afternoon here in Seattle. I know a couple of you are still watching from across the globe and you're probably like over midnight and way into the night, so thank you for sticking with us. Speaking of thank you, I know we've had the Global Bootcamp slides in every talk today, and I really wanted to reach out to all the local organizers and say a big thank you, because you've been really doing a great job in organizing these events locally. If you're an attendee or you want to learn about Windows Azure, go to the website, find a location near you, and come join the fun next week. So thank you, organizers, again. This talk will be about how we made MyGet.org on Windows Azure. So MyGet is a website or web application me and some guys built, and we ran into a couple of issues, and I really want to talk about the issues we ran into, how you can solve them, and what you can do to, well, make your application on Windows Azure scale better. So I'll start introducing myself. I'm Maarten Baljouw. During daytime, I'm a technical evangelist with JetBrains, and during nighttime, I'm the co-founder and also a developer on MyGet. I also run the Azure user group in Belgium, so the Windows Azure user group. And yeah, as you can hear, my big passion is Windows Azure. I try to blog about those things on my blog, blog.maartenbaljouw.be, and I try to tweet on those things or on ice creams like today on my Twitter handle. If you want to buy me a beer, go to Amazon, find my book and buy the book. Or if you see me at the next venue, just buy me a beer. Or we can just have beer together. You don't have to buy it anyway. So the agenda for today is, well, I'm not sure if everyone will know what NuGet is. I'm not sure if everyone will know what MyGet is. So let's start talking about that. Then we'll talk about how we started the website, how we started building this application, why we built it, what we did to start with it. I'll give you a hint of what we did not know at that time and what you may want to know when building a web application on Windows Azure. I'll highlight our different architectures we had. So we're at architecture number 2 today. And we had the first one which wasn't that optimal, so we'll talk about that one as well. I'll have a look at ACS, so Access Control Service on Windows Azure, and we'll have a look at our tough times, or as I like to call them, learning moments, later on during this talk. So NuGet and MyGet. I'm not sure if you're familiar with NuGet, but NuGet is a Microsoft product which helps you find dependencies you want to use in your software. So previously, if, for example, you were building a web application and you wanted to include the Elma logging framework into your application, what you typically had to do was go to Google Codes, download the right assembly, unzip it somewhere on your system, find all the instructions, read the README, and make sure that everything is configured correctly in order to just include a simple DLL and have it working in your application. Now with NuGet, Microsoft did a cool thing actually. They built a package manager on which you can just host a package, for example, Elma. You can search through this package manager, so if you need Elma, just look for it in the package manager console, and you will find it, and you can simply click the install button, which will bring down all the assemblies and which will just configure your web config and things like that. It's really cool because also if Elma publishes a new version, for example, you will see a nice update button in this UI, and you can just update this package to the latest version of the assembly you want to include in your project, which is a cool thing. And if you want to publish your own packages, say you have your own open source project or you have something you want to publish there, you can do so. Just go to NuGet.org and you can publish whatever you want there, and people can consume it through the NuGet package manager console. One major problem with that is that NuGet doesn't really allow you to host your packages privately. So if you have an enterprise or you have a company and you're building your own frameworks, you're building your own tools, it's kind of hard to, well, put them on NuGet.org, because that would mean if you put them there, everyone in the world can see them. So you probably don't want that with the thing that's providing your business the value you actually want to have from the sources and from the binaries there. So that's why we built MyGet. MyGet is a NuGet as a service hosting solution where you can just sign in, create an account, publish your own packages, and have your own local private feed on MyGet. So you can use it from the same package manager dialog window, but it's only visible to you and not to everyone else on the internet, unless of course you want to. We have security permissions, so if you want to give other people access to your feed, that's perfectly possible. There's a couple of other things we do. Like I said, you can store your IP, your intellectual property with us. So it's very easy to just create an account on MyGet, upload your packages, and get started hosting your, all your dependencies for your software. Creating packages can be hard, and that's something we also try to make easier. We have build services in which you can simply specify your GitHub project or your Bitbucket project, whether private or public, and we will try to build it and create a NuGet package of it, which we will publish onto your MyGet feeds. And from there on, you can push it forward to NuGet.org. We also have security, so you can have feed administrators, which can do everything you want to do on your feed, but you can also have simple consumers who can only consume packages and not push packages to the feeds, and everything in between that. We also have a symbol server, so if you push packages and you also push the symbols of those packages to MyGet, you will find that in Visual Studio, if you want to do debugging, the symbols will be downloaded and you can just step through the source code you have within your packages. We also have activity streams, so if you have teams like 5 developers on your team and they all work on the same feeds on MyGet, you will see whatever they have been doing and whatever they are doing, and you can basically see what's happening there. Also, something we are planning in the future, there's a basic version available right now, but we are planning more on the analytics part, where you can see who is consuming the packages that I published on MyGet and so on. I'm not alone. I'm doing this with a couple of other guys, namely Xavier, who is the first one on the slide. You can follow him on Twitter. And also Yves, who is also on this slide. And if you want to just follow all of us, you can just follow the MyGet team on Twitter. Speaking of Xavier, by the way, thank you, Xavier, for staying awake. If you want to chat about MyGet, simply go to the link you see on the slides. Or after this session, if you're not following this live, you can simply tweet us on our Twitter handle. So thanks, Xavier, for doing this. So let's give you an idea on how we started building MyGet. The real beginning of MyGet was a simple blog post on my blog. And as you can see from the title of this blog post, it was titled Using Dynamic WCF Service Routes. Basically, this talk or this post was about how you can host WCF services using ASP.NET routing. So you can have multiple URLs pointing to the same service and just simply use all the parameters in there. That was the real beginning of MyGet, but we didn't know back then. Then NuGet was released, and back then it was still called NuPack. So that's almost 2 years ago. And we saw that they were using OData feeds for pushing all those packages out there. And we thought, well, OData is kind of like WCF. And well, since NuGet is only public and every package you put on there is public, why not use this approach from that blog post on having multiple URLs pointing to the same service for creating multiple OData feeds, since it was WCF anyway. So I exchanged some ideas with Xavier back then, and we prototyped something during Tech Days Belgium in 2011. So, well, it's 2 years ago, so happy anniversary, MyGet. In May 2011, we published our first version of MyGet, and it was just an announcement on our blog, and, well, that's the start of MyGet, which was interesting because we didn't really have a solid solution back there. What did we use back then? Well, Windows Azure, because Windows Azure was the new kid on the block. And we were like, okay, yes, a new toy for us. And we decided on going with Windows Azure there. We also decided on going with Windows Azure Table Storage and Blob Storage, not with SQL Azure. The main reason for that was Table Storage was just really cheap. It was really cheap to get started. And in case we failed with our idea, it will also be cheap to just fail on Table Storage. We did start using Windows Azure ACS though, and the main reason there was, well, I think every developer on this planet has written their own user registration system and their own login system and things like that, and we simply didn't want to do this again, and that's why back then we started using ACS. But right now we have multiple reasons for using ACS, but more on that later. Back then it was also still ASP.NET MVC2, and we were using the Managed Extensibility Framework as a DI container in this project. Did we use any best practices? Well, it's kind of embarrassing, but I would say, yeah, this is the reaction you should have. So we didn't use any best practices there. What we did was simply create create some views, and from those views and from those controller actions, we were simply calling the storage accounts, and that's basically it. No repositories, a lot of duplicate code, a lot of copy-paste errors and things like that. So that was MyGet 2 years ago. Our architecture at the time was also very simple. We only had one web role. Again, it's just an idea that we wanted to test, so we were like, yeah, maybe we can just go with one instance instead of a couple. And we decided to also go with just one storage account, which would contain all the packages, all the feeds being created, all the users, and etc. What we did not know, though, was that this thing would pick up. Users would come. In the beginning, we just pushed this on our blog, and we had some interest from people who were just interested in seeing what this thing was. And they typically created a new feed, but that's about it. They didn't really start using this. Until after a couple of weeks, users started to come. We grew from like 5 users to 70 feeds in a week. And the next week, another 70 would be joining and things like that. So we were thinking, well, maybe we will hit our max soon because this uptake will probably not last forever. That's what we thought back then. Also, data would come. Some people in some open source projects apparently thought that MyGet was a really good idea to push all their NuGet packages to. Whether CI feeds or just large packages they didn't want to have appearing on NuGet, or to have some kind of a staging environment for their packages on MyGet. And what we saw was one user started pushing over 1,000 packages to our feeds, worth more than 1 GB of storage for just that feed alone. And as I said before, the main implementation of MyGet back then was very simple and was totally not prepared for this kind of stuff. So we had to do some things about this. And it was resharper time. So we did some refactoring of our code. We introduced repositories. We introduced solid and dry principles. The things you typically do in software when you actually have a plan on what you want to do. Because with MyGet back then, we didn't really have a plan until, of course, we had to refactor and do things separately or differently. Back then, we also decided on running 2 instances, but that was not really for performance reasons, but more for availability reasons, because more users were coming, and we were thinking, well, we don't want to disappoint people whenever that one server we had back then would go down, so we went with 2 instances there. And we started. Someone mentioned they would pay for our service, which we didn't even think about back then. So we had to come up with a business model. And that business model was to have a public website on which you could register, and have a freemium model on which you can create your own feeds, post your packages, make use of MyGet. And whenever you have a large volume of packages or you need more storage, you would just take one of the plans we had available and you would go there. We also noticed a lot of our users were coming from the EU, but also a lot from the USA. So we were thinking, well, we might have a problem there. And that's where we introduced our first architecture, which looks something like this. Basically, we had a lot of stuff running in the EU West data center. We had our web role, or our web roles there, of course, behind the network load balancer in Windows Azure. And in there, we also had all our storage. So in the one storage account in the EU West data center, our web roles would simply connect to that storage account and make use of tables and blobs and things like that. Also, EU West, we had Windows Azure ACS for all the authentication woes we had back then, and users logging in and things like that. Now, since we decided that, discovered that 50% of our users was coming from the US, we simply thought, well, why not have a data center in the US as well, run one web role there as well, have it connect to the storage account in Europe, and have our website running in the US as well. How do you do this? Well, if you have 2 locations in Windows Azure, there's one of those hidden features called Windows Azure Traffic Manager, which does DNS load balancing. Either DNS load balancing, or in the case we used it, is based on geography. So if you have a user coming from the US, they would end up in the US data center. If you're from the EU or somewhere closer to that location, you would end up in that location. So basically, our first architecture was not 2 VMs in one web role in one data center. No, just one single VM in every one of those data centers. Why? Because we thought whenever we had Windows Azure Traffic Manager sitting in front of that, whenever some location would fail, Traffic Manager would fail them over to the other location. But yeah, we'll see, that was kind of a wrong assumption there. Also back then, we were using the Windows Azure Content Delivery Network. So since we had users on all locations around the planet, so in Europe and in the US, we thought, well, consuming feeds and querying feeds and adding packages to feeds, that's not kind of hard. That's something we can do from all those VMs. But if you want to download packages, and those packages might get quite big, it would be beneficial to have those packages located on a location closer to our users. And that's why we thought about the Windows Azure Content Delivery Network. So all packages published to MyGet back then were also published on the Content Delivery Network, and you could simply download the packages from a location close to you. So we were safe. That was an awesome architecture. We had our data centers nearby our users, so one in the US, one in Europe. We had centralized storage, so only in Europe, and the US server would just connect to the European storage solution. Packages were on the CDN, so we had a really fast throughput. And in case something went wrong in one of both locations, the DNS services provided by Traffic Manager would simply fail over all the requests coming into our solution. But the thing was, this awesome idea we had and this awesome architecture was not really that awesome. Data centers nearby our users? Well, maybe not. In fact, apparently a lot of ISPs don't have the most optimal routing they could have on the internet. So, which meant that some of our users were still ending up in the wrong data center because their ISP was having some strange routing tables there. Also, having this centralized storage where the US server would call into the storage sitting in Europe was kind of like limiting. Speed of light is quite fast, but not if you have to send over a lot of data transatlantic. So speed of light was kind of blocking the performance from the US-based customers. So the USA server was quite slow. Also on the CDN, we had some issues. We typically had some synchronization issues. What do you do if a package updates, but the CDN is still caching the package? So we had no way to purge the cache there and push the new package up to the CDN. Also, the CDN back then was suffering sometimes some downtime, or some files could not be found even when you knew that the file had been cached before. So CDN was not that optimal then. Also, the DNS failover seemed to work mostly. So we tested this and we just shut down one of the servers, for example, in the US or the one in Europe. And we noticed that on our connection, at least, everything was going fine. And like 15 seconds after shutting down one of the servers, DNS would fail over, and we thought all our users would be on the second location as well. Unfortunately, not every ISP around the globe seems to follow all the DNS standards. So this failover mechanism at the DNS level did not really work because a lot of users would still have to wait a couple of hours before they were directed to the other location. So we thought, yeah, maybe that one server on every location is not the most optimal way of doing this. But still, we persisted. We thought we really believed in this architecture, so we did some things to enhance the architecture. So we added local caching in the US. We were still connecting to the European data center to get all our data, to get all the packages, to get all the feeds to search and things like that. But we did add a caching layer in the US. So whenever a package was received from Europe, or whenever feed metadata was retrieved from Europe, we would cache it in the US as well. We also switched to having 2 instances running in the EU and one in the US, basically for availability reasons. So whenever something in the US went wrong, the DNS would fail over, and yes, maybe some users would still see some latency in the DNS switches and things like that. But we thought if we are strong in the EU, whenever one server goes down there, if we have 2 instances, we're safe. Unfortunately, even these changes meant that synchronizing data between both locations kept being slow. Even having the local cache sitting in the US was still proving difficult to get all the data across the wire in a speedy fashion. So that was really, really difficult. Also, populating the cache was like a nightmare. We had some customers using MyGet with themes that were distributed, both in the US and both in Europe. And we saw that populating the cache whenever someone in Europe made a change, it would take some time for the cache to pick up those changes in the US. So that was not really optimal. And we had some conflicts there, and yeah, the cache was really a nightmare for us. Also, the CDN kept having issues. It kept having synchronization issues. It kept dropping packages and things like that. So we really had the idea back then that the CDN was not that good of an option for our architecture. And we also noticed that from those 3 instances, the 2 in the EU and the 1 in the US, we found out that only one of them, if we just copied all the performance counters together, we noticed that in total only 60% of one instance was actually being used while we had 3 instances running. So that meant a lot of costs, and we were actually using less than 1 server of those 3. But we still wanted to have them because of availability reasons. So that architecture was not that optimal, but also we had to pivot in our business plan. We had public subscription plans on the website, so you could go to the website, register an account, and start working with MyGet. But we also added enterprise tenants. So whenever you have a larger team, it's probably more efficient to have your own copy of MyGet running, and that's what we did. We have enterprise tenants. They have their own domain name to use MyGet. They have their own data storage. They have their own authentication mechanism. But while a cool feature and something that really provided value to our customers, we found that our architecture became really, really complex whenever we wanted to do something that was valid for all tenants or just for one of them. Also, caching and syncing became even more complex because for every tenant we had to keep this cache in both the EU and both the US. So it was really becoming a very complex architecture and really difficult to work with all this. So we started thinking about a second architecture which would solve many of these problems. And we started thinking about this architecture based on workloads. So before, our first architecture was mainly a reactive architecture against everything we experienced before that one. But for the second architecture, we thought of looking at our workloads and looking at what might be beneficial for every kind of those workloads. And in MyGet, we typically identify 3 major workloads, which is managing feeds and packages. So whenever you go to the website and you want to push something to MyGet, you can do so through the website, and that's one of the workloads, the management of users, feeds, packages, and things like that. And we thought it doesn't really matter where this is located, and even a little latency when managing feeds and packages is not that hard. It's something you typically don't do continuously during the day. It's something you just do during the course of the day, managing feeds and packages, but not something you do continuously. So a little latency probably wouldn't hurt there. Downloading packages is something different. Typically, if you have a build server consuming packages from MyGet, or you have a development team that has to consume packages from MyGet and use them in your solution, it's probably better to have the download closer to the users. And before we were using the CDN, but again, it was not that optimal back then. So we decided on having storage accounts for every tenant. So every tenant could simply decide where they wanted their packages stored closer to their team, which meant if you are a US-based customer, we will give you the storage location in the US. If you're in the EU, we will give you the storage location there, just to have a faster throughput for all the package downloads. We also have build services on which we simply fetch sources from any of the source code hosting options that are out there, and we build that solution and create packages for that. Well, it doesn't really matter where you do that because it's a real background process. And I mean, it could even run in our own basement on a local computer, but it didn't really matter to have that thing in the architecture and optimize for it because it can happen anywhere, the builds. So we decided to go with a second architecture. And you will see that we were still running, or right now we are still running in the EU West data center. The reason why is that we found it a very stable data center in Windows Azure, and it's close to us, so we have optimal performance in working with MyGet ourselves. We are running on 2 instances in Europe, and those 2 instances are behind the network load balancer in Windows Azure, of course, and they are making use of Windows Azure ACS to provide all the authentication needs we have. Those 2 web roles are connecting to a storage account, which doesn't really contain a lot of data, except for tenant information, which customer has which domain name and which storage account should he or she connect to when using MyGet. That storage account also holds several storage queues in which we provide messaging capabilities. So whenever you do an action on MyGet, we push a message into this queue, and this queue will be processed, and the actions given in that queue will be processed and and apply to the storage we have back there. So whenever you log into MyGet and you go to one of the domain names we have, you will be redirected using Windows Azure Traffic Manager to one of the data centers we are hosted in, but we are only hosted in Europe West, so you will probably end up there. Now, why are we still using Traffic Manager? Well, the main reason for that is we want to have a quick failover in case something does go wrong in Europe West. And what we have is, we have in Europe North and in some of the other data centers in the US, we have fully configured Windows Azure Cloud Services, also included in the Windows Azure Traffic Manager policy, which means if Europe West has a big problem, we can simply upload our latest package to one of the other data centers and Windows Azure Traffic Manager will do the failover to those other locations. So whenever you come into the website, the VMs will decide on the tenant you are, or based on the domain name, and it will connect to a storage account per tenant. So every storage account at the tenant level, and our public website is also considered a tenant, so the architecture is exactly the same for our public website and our private tenants that we have. In that storage account per tenant, we have feeds, we have their users, and of course we have their packages. Most of our tenants are located in West Europe as well, but some of them decided to have the storage account in a data center closer to them. So again, we decided in providing our enterprise customers the option to decide where they wanted to host their storage, and some decide to host in a data center closer to them. But still, all the management happens through the EUS data center there. We also have backups, of course. So it's not that because of blob storage having the 3 replicas of all your data, that you shouldn't have backups. In case of human errors, in case some of your code is very wrong, you probably still want to have backups. So what we do is we back up continuously to a location in Europe North, so in another data center. And in case something really goes bad in EU West, we still have those backups to restore all the data in whatever data center we decide to move to in such situation. It's not real time, of course, it's not an automatic failover, but we still want to have access to the data in case something severely goes wrong in one of the data centers. Our builds are located in EU West, but they could basically run anywhere. And our build machines are simply running on the infrastructure as a service version of Windows Azure. We have a build server there, we created our custom build scripts, and whenever you use build services on MyGet, your builds are being done on one of those machines, and they push to one of the storage accounts depending on the tenants that you are consuming MyGet with. Our first architecture was scaled across the globe. Our second was not really. But we found that our first architecture also was as synchronous as it could be. So as synchronous, not asynchronous, but as synchronous as it could be, which is not optimal when building cloud services, especially based on the speed of light. If you want to do synchronous tasks, so for example, wait until a package has been uploaded into a US data center whenever you are consuming it from Europe, it's prone to all issues around latency and synchrony and things like that. So you don't want to have that in your solution if you want to go global. You want to have something asynchronous. And well, we had a lot of code, and it's always difficult to throw around the entire code base. So we decided to look at event-driven architectures, and we borrowed some concepts there. And we are moving towards a more event-driven architecture with every release we do, but it's not high priority because everything currently scales. But we borrowed some concepts from an event-driven architecture. And here's what we're doing. In MyGet, whenever an action has to be performed, some actions will trigger an I-command implementation on a queue. So our ground rule there is, if it can't be done in one write, we use an I-command that we push onto a queue. Main reason for that is if we want to update the last login date of a user logging in, for example, that's a simple write and we just do it immediately. But whenever you do something more complex on the website, like assigning privileges, or you want to update a password and have it synchronized with our symbol server, that's more complex and something that is probably prone to failure somewhere. So we create commands for that, and those commands go onto a queue. Command is being executed. It's idempotent as well, so the command can be executed several times. And in case something fails, the message simply stays on the queue, and we keep on trying for a couple of times before we move it to a dead letter queue. All actions that we do, even if they are synchronous, like the user who has logged in and we change the last login date, are actions that are completed by throwing an I-event on our queues, which means everything you do in MyGet will trigger an I-event in our architecture to which whatever component we have in there may subscribe. So we have a set of handlers that subscribe to either an I command or an I event implementation, do their work, and get a message from that queue whenever everything is done. Handlers are idempotent, and they do not depend on others. So it might be a natural reflex to have events, and whenever this event happens, you want to have a second event triggered, and then a third, and then a fourth, and you want to have some kind of a workflow there. If you do need that, work synchronously, because events are not meant to work synchronously and in a workflow style fashion. So handlers do not depend on each other, and they are idempotent, so actions can be triggered a couple of times and they will not corrupt the data. An example, whenever a user logs into our website, those are two operations. Of course, we have to go to our data store and make sure that the user logging in has an account and that the password is correct and things like that. And we do want to keep track of when was the last time this user logged into the website. So what we do is we simply store the last login date there. It's a one write, so we do not use our I command approach. We don't put a command on our queue. What we do trigger after this login is a user logged in event, which others can consume and act upon. So for example, if we want to have something which is triggered by the fact that a user logged in, we can do this by simply subscribing to this event. Another example can be changing a feed owner. So you can have a feed and you can change the owner. If you want to transfer ownership to a different person, that's a couple of operations. First of all, we have to read the two user profiles. We also have to read the current access rights for that user. We also have to change the access rights for both users. And then we also still have to push all the privileges to symbolsource.org, which is the symbol server we are using, but that's a third party, which means we have to synchronize with them. So that's a lot of operations going on there. And of course, it's not a simple operation, so we would break our ground rule if we did this immediately. So we simply trigger an I command on our queue, which is a change feed owner command. It will contain the user ID of the two user profiles involved. It will contain the feed to which it applies, and that's basically it. Then we have a handler subscribed to that event or to that command. And that handler, whenever it finishes, will trigger a feed owner changed event, because we want to have that flow of having a command, and when the command finishes, we want to have an event being triggered. So as an example of that flow, imagine you have the queue, and whenever a user wants to transfer feed ownership, he triggers a change feed owner command, which is located in the queue. We will then have a handler, for example, a change feed owner command handler, which subscribes to this one event that may occur on the queue. And once that's done, it will push another event onto the queue. So whenever you trigger a change feed owner command, it will always end up with a feed owner changed event. With that event, we can subscribe additional handlers. So we can have, for example, a symbol source handler, which will listen to that event, and whenever that event occurs, it will synchronize all the data with symbol source. We also have an activity log handler, which will subscribe to this event, and whenever it occurs, it will simply write something in a log file, so we can have an activity stream on the website. So changing this feed owner simply triggers an entire chain of commands and events, which will then be executed and are self-contained and really simple to read and use throughout the application. And of course, whenever symbol source has finished, it will trigger a symbol source event, and whenever the activity log has been triggered, it will also trigger a symbol or an activity log handler event on the queue. So we can subscribe to those things as well. The gain of all this, well, we were able to scale down to 2 instances, but mostly for redundancy. Remember before we were at 60% of CPU usage of one machine? We are now at 20% by using this approach of not having synchronous commands, but simple asynchronous things that are processed by just reading a queue. It's also become way easier to implement new features. So a good example there is the activity log we have on the website. we were thinking about how can we do this? How should we approach this activity log? Should we edit all our code, and whenever an action happens, should we insert a couple of lines of code there and write it to a log? No. We simply can create a handler which subscribes to all the events that we are interested in, like a feed has been created, a package has been pushed, a package has been deleted, etc. We simply subscribe to those events and we log them in the activity stream. So this activity log feature, while it looks big and it's really a major part of MyGet currently, it was really easy to implement, and it only took a couple of hours to come up with the first prototype of the feature. So the gain is really in development speed and, of course, performance and loads on the servers. Regarding storage, one of the questions you may have there is, why don't you use a relational database? Why don't you use SQL Azure, for example, to do all this? Well, I don't really have a good answer to that. When we started with MyGet, we thought table storage was like NoSQL, and NoSQL is for the cool kids on the block. So we thought, let's be cool, let's go with table storage and use a NoSQL database approach. So we didn't use SQL Azure there. And over the course of these 2 years, we've been growing accustomed to table storage, and by using this event-driven approach, we really have no issue in using table storage for whatever we want to do. Yes, you will have to duplicate some data that you have, and yes, you will have to have a system based on events and commands to duplicate that data through Windows Azure table storage. But once you have that in place, it's really easy to use and really simple to use and cheap. It's really cheap to use table storage. But one question may be, if you only have partition keys and row keys on table storage, how do you store your data in a performant way? Because you may know that partition key is actually the only index you have on table storage. So if you have, for example, a feed which has a name and which contains packages which have a package ID and a version number, how would you store that in an optimal way in table storage? Well, since we only have 3 important values there, namely the feed name, the package ID, and the package version, we simply decided, well, let's create a table per feed. If we need all packages for a specific feed, we just know the table name, because the table name equals the feed name. Then within that feed, we use the package ID as the partition key, which means if you query a package from MyGet, we know the partition key and it's a fast query to execute. So we can simply grab the package ID there to query. And typically when you have that, we use the package version as the row key. And the row key is not really an index, but the row key can be used for sorting and uniqueness. But typically whenever we query, the maximum number of results that will come back from table storage, maybe like just 100. So you can easily query those in memory afterwards if needed. So that's why how we are using table storage, for example, there. We also found out that reading a lot of data from table storage might get slow, especially if you have more than 1,000 rows in the result set of the query you are doing. You will have continuation tokens, and you will have to issue multiple requests to table storage in order to get your data. So it's really difficult to do and really slow from time to time. So we decided on caching some tables. Back then, there wasn't a really good distributed caching system, so we decided on rolling our own based on blob storage. Even the biggest feed we have on MyGet currently takes only like 100 kilobytes in blob storage if we just serialize it into a JSON array and put it in a blob. So whenever you query your feed, we simply load a blob there and do our query there. Updating the cache, for example, when you push a package to a feed, you will of course write into table storage, but that event trigger or that thing triggers an event which we have a handler for, which will then repopulate the cache on blob storage. So doing this, like I said, if you have the event-driven approach available in your architecture, it's really easy to come up with this kind of things. Now we are looking into moving this cache to the distributed cache you currently have on Windows Azure, but that's an ongoing process. Windows Azure Access Control Service, that's something we rely on very, very heavily. Imagine managing this. We have our public tenants, www.myget.org. We have a staging environment, which is live, by the way. We have our local host development environment. We have all our customers sitting on different domain names. So for us, those are all different applications. Because their domain name is different, they are all different applications. all those applications can also have multiple identity providers. Our public website, for example, has Microsoft account, we have Google, we have GitHub login, you can log in through Facebook, you can log in through Stack Overflow, and so on. Some of our tenants, some of our enterprise customers are using Active Directory Federation services or ACS or AD to log into their account. So again, way more identity providers and a lot of applications. If you think of all these things, you will find that your code quickly starts looking like a giant bowl of spaghetti if you want to maintain this within your application yourself. And that's where Windows Azure Access Control comes in very handy. So we have our local host, we have our staging, and whenever we do development, we have enabled some of the identity providers there. And all our environments use the same access control namespace. So when we are developing on our local machine, we still are using the same Windows Azure Access Control Service namespace that the public website is using. So whenever we come into the website from our local host, ACS will only give us a couple of the identity providers available. Whenever we use the staging website, we have multiple identity providers available. Whenever a user uses the public website or one of the tenants, we simply decide based on the domain name which access control systems they should have available through ACS. So it's really easy to do this using Access Control Service because the application only has to trust this one service, namely ACS. And within ACS, you can configure all the domain names, you can configure all the identity providers and just simply link them together and make sure that all the requirements are fulfilled there. One of the big benefits why we started using ACS is that, well, users typically have some identity that they can use in a federated fashion. So most of our users have either a Microsoft account or a Yahoo account or a Facebook account or a Google account, which they can use to log in. So initially we thought, let's not build a new user registration system and just use one of those. And you might have noticed that ACS is kind of limited in choice there. You only have Microsoft account, Yahoo, Google, and Facebook accounts. And we wrote some of the other approaches ourselves. So if you want to log in using GitHub, MyGet can do this. If you want to log in using Stack Exchange, MyGet can do this. So since we have built those providers, we thought of creating a spin-off for that. So if you go to socialsts.com, that's our first release where you can use LinkedIn, where you can configure GitHub, and so on for use with Access Control Service. A very important thing in this architecture using ACS is there's no real difference between environments, which is also an interesting thing. Say, whenever we have a bug in our application, we can simply download a user from our public tenants. We can download all his feeds and all his packages and things like that to our local machine. And that same identity we had on the public website will now exist on our local website because ACS is managing this identity, which greatly reduces the amount of work to simulate an environment in which a certain bug may occur. Another thing is that our application simply has to know only about ACS, so not about all the other identity providers. Simply trust one service, ACS, and ACS is configured to provide just some claims about the users that are logging in. So it's really easy to develop against. Every tenant also might log in using different identity providers, and ACS will simply look at the host name, and based on that we give a different choice in logging in. So some of our tenants only have their ADFS and we will log them in using their own domain credentials. Other customers have a local ADFS and they have a Microsoft account, for example, or some of our tenants simply used to have all the identity providers available. And yet again, we don't have to change our code whenever we want to do this. We can use ACS, reconfigure it, and have fun there. We've also had some tough times building MyGet, and tough times are typically also good learning moments. So that's why I decided to not title this slide Tough Times, but instead Learning Moments. And one of our really big learning moments was July 2nd last year. You can read the full story on our blog, but basically what happens was a couple of symptoms started occurring. On Twitter, we saw some users complaining about downtime. On our email, we were receiving support requests of people saying that the website was down and they couldn't manage their packages and things like that. So we went to the website and we saw it was working. It was kind of slow, but it still was working. We were also not receiving any SMS monitoring. So we are monitoring the website using SMS monitoring and a lot of other tools as well. But we didn't get any messages there. Until half an hour after the first symptom occurred, we noticed that we were receiving a ton of SMS messages, which were saying side up, side down, side up, side down. And if you look at the image on the slides, you will see, well, that's what was basically happening. The monitoring was looking at the website and noticing the website was down and then up again and then down again and up again and so on. The really strange thing was if we logged into the Windows Azure Management Portal, we were not seeing any signs of any issues on our website. So what was the cause? It was right after we introduced our second architecture. So some things had changed. We just deployed our multi-tenant architecture in which we had the different customers with the different domain names. We also just enabled storage analytics back then. And when we were looking at the ELMA logs we were seeing that we were getting throttled on storage. So we were thinking either we have a bug in the multi-tenancy things, or either by enabling storage analytics, we are being throttled because those things are writing too much to our data store, because those were the symptoms. We also noticed that in our queue, handling all the events and the commands, we had like 16,000 unprocessed commands being queued and queued again. So nothing was really happening, but we saw some more symptoms there. After 4 hours of digging into our code and simulating other things, we found that one single line of code brought down our entire website. So on the package object, whenever you have a package, we implemented a get hashcode method and an equals method. And for some reason, we were returning duplicate values there for some of the packages. So you could have package A and package B, which were in essence different packages, but they would still yield the same hash code, which is, well, a very bad thing. Because if you're using table storage, those things are running on data services, and the data services proxy you have in your local code will check the hash codes to determine uniqueness and things like that. And because the hash code was yielding duplicate values for some packages, that thing was simply throwing unhandled exceptions. Good question may be, unhandled exceptions, and that's what crashed your website? Well, no. We were actually catching every exception occurring in our code. Whether front-end, whether back-end, we were catching every operation and every exception that was happening there. But what we were doing was blindly retrying every operation. So every exception that occurred, we retried the operation, which meant if this thing was throwing unhandled exceptions, we were still queuing a new retry of the same operation again. Having all that and having reads and writes to storage basically caused storage throttling, which was the main reason why the website was being degraded and becoming very slow. Because the website also reads from storage, and because the storage account was being throttled because of the writes on the backend, the website was being throttled as well. And the website was also retrying reads, causing even more load on the storage accounts and causing even more throttling, which meant that basically we were just starving IIS worker threads, and basically our entire thread pool was occupied with just catching exceptions and retrying operations. So lessons learned there is that a simple bug in your application, just one line of code, can halt the entire application, and some things may seriously go wrong because of one single line of code. Also, if you do want to implement retry logic, and I strongly suggest you do so using any of the services in Windows Azure, only retry transient errors. So for example, if there's an intermittent network failure, retry that operation, but do not blindly retry every exception you have in your code. Have some safeguards there and be smart about what you are doing. Also, our monitoring was not the best thing we had because it was still saying that everything was okay, even though the website was being slow. So we had to add some monitoring there. We also found some bad untested code there, and that was still some codes that we had from the MyGet original blog post there. A second downtime we had, so that was a first strong downtime we had, and we solved and we implemented measures. We have more monitoring in place right now. But a second huge downtime was this year, February 23rd. If you are doing Windows Azure, you will probably know what was going on that day. But we found out that our entire website was down, our storage was down, we had furious users on social media and on email, the management portal was down, and we also noticed that there were furious tweets using the Windows Azure hashtag as well. The cause of that thing, well, it wasn't too hard to guess. Windows Azure was down globally because of an expired SSL certificate on storage. So, well, we started thinking about our application and how we might do things differently if something like that happens. So, because we were connecting to storage using the HTTPS endpoint of storage, basically our website started crashing because we are using the HTTPS connection. The SSL certificate expired and our code was simply refusing to connect to storage, causing downtime there. So some considerations we did was, well, should we move over to the HTTPS endpoint or to the HTTP endpoint instead of HTTPS? And we decided against it. I think Microsoft learned about this event and they will probably not do it again, at least I hope. And we still want to have a secure connection with our storage because some of our tenants are in the US, that data is traveling across the internet, so we want to have transport layer security in there. So we will stay on HTTPS. We also noticed that if Windows Azure has a global downtime, we have a downtime as well. And that's a very tough one to tackle. And we were thinking about maybe failing over to another solution out there, maybe some hoster, maybe another cloud vendor, in case something really went wrong. Now the problem there is that they have different components and it costs a lot of money to keep a second environment up and running there. So we decided against it for now, but maybe it will change in the future. What we did consider, and what we are doing now as well, is having off-site Windows Azure storage backups. So we were doing backups from EU West to EU North, but we are now also copying those backups to an off-site location. In case something serious happens to the platform, we still have our data, in case it doesn't get restored as fast as we want to. Another nice thing where we learned is introducing new features. Before, we didn't have something like retention policy. So what you would typically do is deploy your packages on MyGet, post your packages to MyGet, and you would have feeds with tons of packages. Now, typically, if you're doing continuous integration and you just want that build being pushed to MyGet, some of our users didn't really want to have all those packages on MyGet. So we introduced retention policies, which will basically clean up the entire feed whenever necessary. So for example, you can say, I only want the 10 latest packages, and everything older than that will be cleared. Now that feature proved to be a success, and a lot of users activated it from the moment we announced it on Twitter and on our blog and on our newsletter. And we found out that there were 3+ million commands queued in our event queue. So the solution there was to scale out to multiple instances, which only took a few minutes to process this entire queue. But still, in the future, whenever we think a feature is going to be big, we will probably use some feature toggling and provide the feature for a couple of users and slowly increment the amount of users that has access to this specific feature, just to spread the load on our entire system. But overall, we cannot complain. Our uptime is quite good. We don't have that amount of downtime since the past few learning moments. So yeah, quite good to work with. I also want to give you a quick bonus tip on doing a startup on Windows Azure or doing any startup on the internet. We found out that a lot of books on startups are saying measure everything. So we were thinking, okay, we want to measure everything, but what do we have to measure and how are we going to tackle this cookie technically? So we decided to use an existing platform there which does analytics on Google Analytics, and we created a small library called Google Analytics Tracker, which you also can use in your projects using this NuGet package. And we are using that to track every feature that's being used in the application. So here's an example of what we see on Google Analytics. And we basically track every feature that's being triggered. So the first one in that list from last month is the reason why we implemented a traditional username password login system, because apparently a lot of users were using the traditional login system. So we decided to build a traditional registration system anyway, because a lot of people were using it. We also found out that build services is always on the second place in our ranking, which means we have to keep investing in building out build services there. We also found out that feed discovery is quite popular. Feed discovery is a way of discovering the feeds that you own by adding a simple meta tag to your website or to your blog. And whenever we released this feature, we were thinking maybe we will have 2 or 3 users making use of this feature, but it's showing up in our top 3 most used features on Google Analytics for the past 2 months. So we really have to do something about it and make it even more popular and keep investing in that one as well. One feature we do not see in this list is download feed as zip. A lot of users were asking for backups of their feeds, and we implemented a feature where they could simply click a button and download a zip file containing all the packages of their feeds. Well, we found out that apparently it's not really being used, even though we were thinking that this might be a killer feature that everyone wanted to use and would cause a lot of technical stress on our system. But apparently no one is using it. It doesn't show up in our stats. So yeah, measure everything and you will learn these things on what to build next. That being said, the conclusion of this talk, we saw NuGet and MyGet. So NuGet is a package management system. MyGet is something which allows you to optimize your package management in your development process. We started simple. It basically started with a simple blog post, which we wanted to use WCF and routing. We did build a product out of it, and we did not know some of the things, like we would get users and users would want to pay for this. So we had to implement an architecture, which we had to revise again, and we think we are quite stable now, but who knows, in the future, a third architecture will evolve out of this. We are using ACS for 2 reasons, mainly for not having the registration pages and simply have some of the social identity providers out there for authentication to our websites. And we are also using it for managing tenants. So every tenant gets their own domain name, and based on that domain name, ACS will decide how they can log into MyGet. We had some tough times, but tough times provide learning. So if you're doing something on Windows Azure, whenever you have tough times in your application, do look at what happened and try and learn from those things, either technically, either conceptually, or either business-wise. And also, speaking of business-wise, measure everything that's happening in your application and try to react on it and try to decide on what features to build and not to build using that approach. With that, I see that I have one question. If you could do it over again, would you use a relational database? That's a good question. If you asked me this question a year ago, I would probably say yes, we would have used a relational database. But since we introduced our second architecture using the event-driven approach, where we can have duplicate data which is populated automatically by simply reacting to all the events happening in our system, it's actually very easy to use table storage and duplicate data as long as you have one master somewhere which is triggering events and things like that. So we would probably not go back to relational database there. Table storage is proving very stable. It's very cheap, and it's quite performant if you know how to use it and if you think about how you're going to query everything. So probably not a relational database in the future. Since that's every question I see on my screen, let's conclude. I want to thank you for joining AzureConf, for joining my talk. You can find more information on my blog, on my Twitter. You can buy the book, and if you're interested in package management, simply go to myget.org and go wild. Thank you.